Very easy questions. Don't worry. Okay, Akshita,
Yes, ma'am.
are they visible to you?
Yes, ma'am.
Okay, done. Just do this. I'm not disturbing you. Just 2 minutes of the time, okay? You have to be quick because it's easy.
Yes, ma'am. Is it zero, ma'am, for the first one?
Akshita, are you done?
No, ma'am.
Yeah.
Is the first one zero, like the second question?
No. A bird weighing 200 grams sits on the tree branch. How much work does the bird do on the tree? Yeah. So what is the answer?
It's force into displacement to cos theta, right?
Work
Uh,
done. Yeah. Force into displacement into cos theta. Right. Then.
so the work done would be like, is it zero?
Okay. Like you had sorted it with.
Bird, since the bird isn't going anywhere, so will the D be zero? So the whole
Okay.
will be
So
zero, right?
here is the tree, suppose, and
Yes.
here is your bird sitting. Yeah.
They haven't
Yeah.
given any specific number or value
Yeah.
for.
Yeah. I know. I know they had not given. Okay. So basically, what is happening? The weight is 200 g. So
Yes,
this is 200.
yes, ma'am.
Correct?
Yes, ma'am.
Done. So how much work does the bird do on the tree? So how much work it is doing? So force is there, that is 200, but displacement is 0.
Yes, ma'am.
Correct? Hence
Yes,
it will be 0.
yes, ma'am.
Move ahead. As a box slides on the floor, it is slowed down by a constant force due to friction. If this force is 150 Newton and the box slides for 2 meters, how much work is done against of the frictional force? Yes.
1 second.
Oh, you have not done it. I have thought you are done.
No, ma'am. I just did the second question. I asked if it was zero, but I
Oh,
think
perfectly fine.
gave
It's okay,
me.
it's okay. Yeah, got it.
300 joule, ma'am. 300.
300 joule you have sorted. Okay. So the force is 150 newtons. Done.
Yes, ma'am.
Okay. And your answer to is force is how much? 150 newton.
Yes, ma'am.
Okay. After this, slides for 2 meters. Okay.
Yes.
Work it is asking. Okay. So where is the cos theta? Is it not given?
Mm. I think
Yeah. Go ahead. Hmm.
is it cos 180?
Is it how much?
Cos 180?
The box is sliding along the floor. Acceleration is here.
Yes, ma'am.
Slowed down by a constant force due to friction. So frictional force is over here. Box slides for 2 meters. Let's say it had reached here. How much work is done in against of the frictional force? So in against of frictional force, it will be cos 0. So 150 into 2, it is 300
Okay.
joules of
Yes.
the work done. Okay, it is asking how much work is done. So work is done over here in against of frictional force. So frictional force needs to be applied for 300 joules. Okay.
Yes, ma'am.
Okay. Any doubt?
No, ma'am.
Great. Now moving ahead, we have sorted the energy part in which I had explained you potential energy,
Yes,
right?
ma'am.
And we were about to solve elastic potential energy, right?
Yes, ma'am.
Okay, let's solve for that. So moving ahead, I'm starting with the next topic, and that is elastic potential energy. Just have a look. So elastic potential energy is defined as energy possessed by any object due to its shape and size. Okay. So if suppose I am having here a spring which has been stretched in this direction, so I am applying a deforming force. Hence it will be extended, let's say till here, in this direction due to the availability of deforming force. So the amount of extension, let's say, is x. So therefore the force applied will be equal to minus kx, right? And
Yeah.
the elastic potential energy will be equal to half k x square, as f equals to kx. Hence my EPE can also be defined as half of fx. Clear?
Yes, ma'am.
Okay, so these are the equations for elastic potential energy. You want to ask anything?
No, ma'am.
Okay, so basically here this is the second energy. Next is your kinetic energy. So kinetic energy formula is also very easy. The energy possessed by any object due to its motion. Okay.
Yes, ma'am.
Okay, done. So now kinetic energy is like how? Suppose this is a ball which is moving with initial velocity u. It had reached here and the final velocity is v. Okay, so the work done is defined as F dot delta S. So work done is equal to ma dot a delta S. Understood? Any doubts?
No, ma'am.
Great. So obviously here we are aware that if we apply the equations of motion, v square equals to u square. What is the equation? Tell me.
V square is equal to use which
Mhm.
one? The one with the circular thing?
Yeah, velocity and displacement. equation. It's okay if you are not aware. V square minus U square equals to 2as. Okay, this is the Newton's third equation of motion. So, initially it was at rest, hence V square will be equal to 2as for this. Done. Now, if I bring 2 over here, it will become V square over 2 equals to as. I will apply this as in this equation. In this equation. Done. It had changed the length, it had changed the displacement, and which is s, right?
Yes, ma'am.
The distance that it had covered from here to here is how much? Change in distance is s. Displacement. So if I apply it over there, so my W will be equal to, I'm applying it over here. Just check. M into V square over 2. Correct?
Yes, ma'am.
So as it had changed the displacement, how much? V square over 2. So I got my equation for kinetic energy. This is 1 by 2 mv square. Understood?
Yes, ma'am.
Any doubts?
No, ma'am.
In all of these situations, a very important thing, that is the law of conservation of energy is working. Okay, and what does it say? That energy can neither be created nor be destroyed, but it can be transferred from one form to another. Okay?
Yes, ma'am.
Done. So as per this, whenever they are giving you some situation, let's say here I am having a slider where I am having a roller coaster in which I am having a car. Okay, just spare me with my diagrams. I draw it like that only. Okay, let's see. It is having a velocity over v over here. And let's say the radius for this particular section is r. So I can say that centripetal force, isn't it?
Yes, ma'am.
Okay, and if I write here the total number of forces, obviously potential energy is converted into kinetic energy. So the total energy for every action is what? Kinetic energy plus potential energy.
Yes, ma'am.
Done?
Yes, ma'am.
I hope I'm right time here.
Potential energy.
Yes,
Okay.
ma'am.
Okay. So hence my half mv square will be equal to centripetal force. So here the centripetal force is how much?
Here the centripetal force is half
mv square. mv square over r is the formula. Okay. Are you aware of this formula?
Yes, ma'am. Yes, ma'am.
Okay. And as it is coming from a height, let's say this is the height from where it is coming. So I can say here I have converted my mg, that is equal to how much? Mg I had converted into mv square over r. Isn't it? From here my car had started. It slided down. Then it goes over here. Then it will take a circular motion. Understood? How is it going?
Yes, ma'am.
Okay. So my mg h is equal to mg equals to mv square over r.
Yes, ma'am.
Okay. Or if I tell you what is my mgh, then my height is nothing but, if it is going suppose like this vertical motion, then it is covering height of 2r, isn't it?
Yes.
What is the height it had covered? 2r.
Yes, ma'am. 2R.
Yeah. So that's why I can write it over here that mgh will be equal to mg into 2r. Correct?
Yes, ma'am.
Done? Any doubts?
No, ma'am.
Great. So if my mgh equals to mg2r, I know that wait, mgh is equal to half mv square. That means the conservation of energy law says that the potential energy gets converted into kinetic energy, right?
Yes, ma'am.
Okay. Anywhere you are finding difficulty?
Till now, no, ma'am.
Okay. So potential energy got converted into kinetic. And here I can say with the comparison of this equation and this equation, I can say that my half mv square is nothing but half mgr. Check. Same equation.
Yes, ma'am.
What did I say? mgh equals to,
mgr square.
yeah. Okay. So mgr square. Where did I written that? Where is it gone? I had written it. Yeah, here. mg equals to mv square over r, right? So m and m will get cancelled out and my g equals to v square over r,
Yes,
isn't it? So my g equals to v square over r. So v square will be equal to gr, right?
Yes, ma'am.
Okay. Any doubts?
No, ma'am.
Great. So I think this is how you will convert the energies in your given question answers also. Okay. Likewise, I will give you one question. It's easy. I'm explaining it to you.
Yes.
Mm. Check. So here is the question. A ball of velocity 200 gram is thrown vertically upward with a velocity of 2 meter per second as shown in the figure. Use the law of conservation of energy and calculate the height. Okay, in your board exam, they will not tell you that use the law of conservation of energy. You have to apply your mind, okay, that I can use for energy, because here see only two variables are given. One is mass and one is velocity. So mass and
Yes.
velocity is half mv square.
Yes, ma'am.
Okay, so this is how you can actually apply that. Yeah, this will give me a, because they had told you to calculate maximum height, right? So if I compare it like this, half mv square equals to mgh, suppose will get cancelled out. Okay,
Yes,
height I have to find, so I will be like half v square over g. G is constant, velocity
Yes,
is already given. Check. Any doubts? How you will
Yes,
do?
ma'am.
And as it
No,
is
ma'am.
going vertically upward, so you can write that the loss in kinetic energy is equal to gain in potential energy. Why I'm saying gain in potential energy? Because as the ball is going up, it is gaining the height. So my formula for mgh is this. Okay. So basically these two are constant terms. So as you gain the height, it will be directly proportional to the potential energy, right?
Yes, ma'am.
Akshita, any doubts?
No, ma'am.
Okay. So now after this, uh, will you do one question related to this?
Okay.
Let me very quick and solve one question. Okay. Because here also nothing is given. It's just that you have to apply conservation of energy rule. Check. Can you see the question?
No. The block slides down the frictionless ramp shown in the figure. Use the law of conservation to find speed when it's bottom. So we need to find V. So if we use mgh is equal to half mv.
Okay. बैठो आराम से
नहीं मैं बैठी बैठो मैं बैठो ये चीज नहीं होती.
Yes, Akshita, say.
I'm doing it, man. 1 second.
Yeah.
mgh is equal to 5.
Okay. Tell me which variable is available with you.
1 second, ma'am. I think it is V is 10. Speed is 10 meter per second square.
Hmm.
Speed
How much?
10 meter per second square.
It's correct. Now you understood now how they will give you and how you have to attempt.
Yes, ma'am.
These questions are definitely coming in basically in MCQ part. Okay.
Yes, ma'am.
Okay, done. Now after this we are having next part, and that is stores of energy. So what is the stores of energy? Basically we are having these energy syllabus for us. First is petrol, that is fuel energy. Then we are having solar energy. Then we are having the gas energy with us. And then fourth is nuclear energy. And the fifth part is electricity. This is
Yes.
in our syllabus. Okay. So just write it and do the study. Okay. So if I show you that how much is available for us, if I talk about the petrol energy or the fuel energy, okay, let me show you the graph for this.
Yes, ma'am.
Okay, so these are the different fuels that contain different amount of energy. Okay, and the physicists have compared these energy contents of fuel in terms of energy per unit volume. That means this is the energy density diagram. Check. Okay, so with the coal, we get 72% of energy, crude oil is 37%, diesel is 36, sugar is 26, vegetable oil is 30, and wood is 3. These are the energy densities. Are you getting, Akshita?
Yes, ma'am.
Okay, related to this, we can also draw one diagram which is known as Sankey diagram. Very rarely it comes in exam, but still you should be aware of what is Sankey diagram. So, what is Sankey diagram? This one is known as the Sankey diagram. Check. What does it convey? That how much amount of energy is being used in a given process. Okay, let's suppose we are talking here about the burning and moving the parts of the engine. Okay, so in an given engine, how much energy is being utilized, and in what type they are being utilized. Okay, so the customer which is driving uses this much part of energy. Okay, the
Yes, ma'am.
transfer of energy from petrol to engine takes this much of part. Okay, the transfer of energy from petrol to I should say this is the power stations, so this much amount of energy is being used. Okay, and the thermal energy which is lost in the power stations is this much. Understood?
Yes.
Okay, any doubts? So this is the Sankey diagram, okay, Akshita, for a given process, and you will use these diagrams if it is coming in exam.
Yes, ma'am.
Okay, fine. So the formula for energy is again the same. Energy formula and the work done formula is always the same, which is nothing but F dot delta S cos theta. Okay,
Yes,
done.
ma'am.
So now when you are applying this work done, if it is given in concern with the position, you will say mgh. If it is given in concern with the motion, you will say half mv square. If it is given in concern of the spring, then you will say half kx square. If it is given in the exam with concern of the elastic potential energy, you will write half of fx. So all energy form, you can compare it with this equation and you can solve your given question answer in exam. Any doubt?
No, ma'am.
Sure.
Yes, ma'am.
Okay, done. So after this, let's calculate uh, the efficiency. Okay.
Yes, ma'am.
So efficiency has been defined as what is the total useful output. Okay. Output what? It could be energy, it could be power, anything. Done?
Sure.
Okay. So it could be okay. So it could be total useful output, energy or power, anything you can use, Akshita, okay? Over
Yes,
input, power or energy. Done?
yes,
Okay,
yes.
Akshita? Any doubts?
No, ma'am.
Okay. So output power over input power or output energy over input energy will give you the efficiency of any given system. Done? And if they are asking you for efficiency percentage, then you will use the formula energy output over energy input multiply 100. You just have to multiply 100 with this. Done?
Yes, ma'am.
Okay. Now after this, we are having two types of collisions. That is elastic collision and inelastic collision. Okay. So what is elastic collision? In elastic collision, before collision, whatever the energy and momentum happened. What is momentum, Akshita?
Laws, uh, laws of uh, conservation.
Are you aware, Akshita, what is momentum, bache?
1 second, ma'am. 1 second, ma'am.
Hmm.
Uh, I'm just checking my data booklet, ma'am. Just give me a second.
It's okay.
Mm, mm, um, momentum, momentum. Impulse. Momentum is mass into velocity, but
Yes. Okay, let me explain you in simple words, Akshita. It's okay. See, if any motion is happening for a given mass, let's say I'm having a mass m which is moving with velocity v. So this particular thing is defined as your momentum,
yes, ma'am.
which is designated as p.
Yes, ma'am.
Okay, you will denote it with p. Done? Any doubts?
No, ma'am.
Sure. So p equals to
Sure, sure.
mv. This is nothing but momentum. Okay, so I'm saying energy and momentum before collision is equal to energy and momentum.
After collision.
Yeah. If they are equal, see separately how much so ever energy it had used, it has used. Suppose it is 30% and it is 40%, but before it was 50% and 50%. Okay. So
Yes, ma'am.
it has handwriting here. Okay. So here it is 50% and here it is 50%. And these are 30% and 40%. So if I just wait, this is this will be 70%, let's say, and this is 30%. So you can check here that the total is same, 100 and 100. So energy and momentum have got conserved. Okay. So before and after collision, if your energy and momentum is conserved, that this type of collision will be known as elastic collision. Understood?
Yes, ma'am.
Okay. And the formula is different for both. I'm writing one by one. First is conservation of momentum, which is momentum before is equal to momentum after. Okay. So this is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay. Second one is conservation of energy, according to which your kinetic energy before is equal to kinetic energy after. Done? So it will be half
mu
yeah,
mu square is equal to
yeah, exactly. Okay. One numerical for MCQ is definitely coming for this formula, any of the two. Please remember these formulas.
Okay.
And yeah, you should also be aware that you have to apply these formula only.
Yes.
Okay. So what is elastic collision? Elastic collision is a collision in which both the momentum and kinetic energy are conserved. Understood? So
Yes.
now let's come to the next point, and that is inelastic collision. What is inelastic collision? So basically, in inelastic collision, the momentum and energy are not conserved. Okay?
Yes.
They can change. Okay?
Yes, ma'am.
Okay. Due to the external factors. Okay? So like if I suppose I have a bomb over here of 120 gram, it got blasted. One got separated as 20 gram. One got separated as 100 gram. Okay. It had gone in this direction, let's say with a speed of 25 meter per second. It had gone in this direction, let's say with a speed of 5 meter per second. Done. So how much energy you have gained, that you can calculate with the help of kinetic energy after minus kinetic energy before. So in this case, you will apply this formula. Okay.
Yes, ma'am.
Okay. Any doubts?
No, ma'am.
Great. Now let's come to the next point, and that is power. Okay. So what is power? So power is basically defined as energy over time.
Yes, ma'am.
Okay. Or even you can define it as work done. Sorry. Work done over time. Okay. SI unit is watt, which is represented as caps W. Done. Now, the next formula is, if it is coming from the chapter of electricity, then power is having the formula VI. Okay.
Yes.
If it is coming from the chapter of force, then power equals to force into velocity.
Yes, ma'am.
Okay. And in electrical chapter, we are having one more formula, that is V square over R. Electricity chapter only, another formula is I square R.
Yes, ma'am.
Okay. Done?
Yes, ma'am.
Any doubts still here?
No, ma'am.
Okay. So these are the formula for power. Now you can find out with the help of power energy also. Okay. That energy is equal to power into time. So if it is given from the chapter of electricity, like find out the thermal energy. So thermal energy is nothing but the heat energy. So heat energy is having the formula. If they are asking to calculate heat energy, so it will be I square RT. Why? Because power equals to I square R. So here I will apply this formula I square RT. So heat depends upon three factors. Square of current, if you supply double of the current, if you give single time of the resistance, and if you provide it for a longer time. Done? So the heat energy increases for a given conductor. Done?
Yes, ma'am.
Making sense? Any doubts, Akshita?
No.
Till now everything is clear? Now, energy is calculated in two ways for the power connected formulas. One is watt second. One is kilowatt hour. Okay. So, if you had been provided with energy in joules and time in seconds, then you will find the power in watt. So if you are finding the energy in joules, you will use power in watts and time in seconds. These are the SI units, Akshita, you have to take care of.
Yes, ma'am.
Okay, but if you are finding it in kilowatt an hour, then your energy will become here kWh. Okay, and 1 kilowatt hour is equal to 1 unit of the energy in electricity meter. Okay,
Ma'am.
understood or not?
Yes, ma'am.
Sure.
Ma'am.
Okay. Now, if I want to convert kilowatt hour into joules, because both are energy only, so what I have to do? I will do it like this. 1 kilowatt hour is equal to, how much is 1 kilowatt? 1000. How much is hour in seconds? 3600. So it will be 3.6 into 10 raised to 6 joules. Okay. So this is the conversion of kilowatt hour into joules. Understood?
Yes, ma'am.
Any doubts?
No, ma'am.
Sure. Okay. So this chapter is over, 8.3. Now I'm starting with 8.4. So you can take a 2 minutes of the break and you can go through the whole syllabus, whole concepts which I had explained. Done?
Yes.
I'm starting with 8.4.
Ma'am, you can go to the share option and add my mail.
Okay, Akshita. So I'm starting with 8.4. You were saying something?
Yes, ma'am. I was like just telling you that if you go to the share option, right, on the right,
Hmm.
you can add my mail and it will automatically share me these notes.
Miss Sonia will provide you the notes. I had told you this before also. She is recording it.
Yes, ma'am. But I feel like recording is also good, but for like
Note making you need.
Yeah. For notes, like I can't like each time, like if I need something in specific, I can just scroll and read it in notes. But recording is like we have to listen to the whole thing.
Mm-hmm. Okay, let me give a talk to Miss Sonia and accordingly I will provide it the whole thing to you. Okay?
Okay, ma'am.
Done. Don't worry, I will provide you. Okay, Akshita, no need to worry about it.
Yes, ma'am.
Okay? Okay, let's move to the next topic, and that is rigid body mechanics. In our rigid body mechanics, it's already our next part, and that is torque. Okay, let's talk about torque.
Yes, ma'am.
So, what is torque? So, basically, torque is defined as F dot delta S sine theta. Just the next part of work done. In work done, we have F dot delta S cos theta. Here we have F dot delta S sine theta. Okay.
Yes.
So, this is the formula. Okay. Now,
Yes.
in rotational motion, what happens is we have this type of force. See, if I have linear displacement, I will be having theta, that is angular thing happening with me. Okay, I will stand over here and I will observe my activity happening from here to here. So this is now angular. Whereas in displacement, you move your position from one to next, right? Okay, so
Yes.
these are the changes that you observe from linear to rotational. So in our syllabus, now we are been added with one new terminology, and that is rotational motion. Okay, so same as displacement linear is converted into theta, your V is converted into omega, so your here F, which is converted into torque.
Yes, ma'am.
Okay, any doubts?
No, ma'am.
Okay, like I can give you one example. If suppose I have the door and here the jacks are working for it, so that the door can be dragged clockwise and anti-clockwise. So these jacks are providing it the torque. Understood?
Yes, ma'am.
Any doubts?
No, ma'am.
Sure.
Yes, ma'am.
One more example. Suppose here I have a seesaw and it is pivoted at the center. Here if you apply the clockwise force, so from here it will go like this. So this particular thing is acting as the torque provider.
Yes,
Okay.
ma'am.
Any doubts?
No, ma'am.
Okay. So if this is the torque provider, basically what it is doing, it is rotating it. Okay. It is rotating it. It is going clockwise like this, and from here it will come anti-clockwise. So this thing is providing the torque. Okay. From here the force has been applied.
Yes,
Delta S is this much. This is delta S. This is force. Now sine theta. So basically sine theta is sine 0 is 0 and sine 90 is 1.
Yes, ma'am.
Okay. So if they both are acting at 90 degree, in short, formula is what? F sine theta, sorry, F dot delta S, no?
Yes, ma'am.
My bad. F dot delta S sine theta. Okay. So what is F dot delta S sine theta? In between these two, this angle is situated. It conveys me like this. Whenever you are having any mathematical formula and the angle is given at the next end. Okay. So before that, whatever two variables are been situated, angle is talking about those two. So here my F has been applied like this and delta S is this. Okay. So in between these two, the 90 degree angle. 90 degree, you will get the maximum torque. You will get the
Yes.
maximum torque. Whereas at 0 degree, you will get no torque. So if I align force also like this, will it going to be get rotated? It will
Yes.
not rotate, but it will be pushed. If suppose I have this block and I am pushing it in like this direction parallelly and the
No,
displacement,
it won't.
it will be pushed linearly. It will not rotate. So for
Yes, ma'am.
rotational motion, your force should be at 90 degree. First thing. Then
Yes.
at pivot, okay, it should be freely moving. So when it is freely moving, pivot is what basically? The center of mass.
Yes, ma'am.
Other than center of mass, if you are applying a force at 90 degree, the object will rotate.
Yes, ma'am.
Any doubts?
No, ma'am.
These are very small terminologies, just you need to understand this factor, okay, and nothing is hard over here, don't worry.
Yes, ma'am.
Okay,
Yes.
now I'm writing the definitions for you. Just do let me know if you are not able to understand any.
Okay, ma'am.
So what is torque? Torque is basically force multiply the perpendicular distance from the
Fine.
line of action. Of the force to a point. Okay. So force multiply the perpendicular distance. This is the definition. Okay. Or even you can say the turning effect of force is known as torque. Okay.
Yes, ma'am.
Anywhere you're finding difficulty?
No, ma'am.
Okay. After this, let's come to the angular speed. So what is angular speed? Because if you provide a turning effect, it will go under angular speed. Okay. So angular speed is the angle swept out by the bar per unit time. Okay. Or even you can say angle swept out per unit time is the angular speed. Now what is angular acceleration? It is the, okay, it is denoted as alpha. It is denoted as omega. I hope you are aware, right?
Yes, ma'am.
Akshita, anywhere you are finding difficulty?
No, ma'am.
Okay. So it is the rate of change of angular speed. Okay.
Yes, ma'am.
Okay. Now what is equilibrium point? Tell me.
The centered position. The
Where the clockwise movement
becomes stops.
no equals to anti-clockwise movement. What is movement?
And there is when the sine theta is
F dot perpendicular distance. This is moment.
yes, ma'am.
Okay.
Yes, ma'am.
Till here any doubts?
No, ma'am.
Great. Now let's come to the next point, and that is the sum of all the forces acting on the body. I'm going so fast. Is it like that?
No, ma'am.
You are understanding the concepts, no?
Yes, ma'am.
Okay. So basically what happens here, Akshita, that if all the forces acting on a body are added, okay? Like I will give you one example. Suppose I have here force F. In this direction, suppose I am applying one force. In this direction, applying suppose second force. Okay.
Yes.
So these diagram can be drawn something like this. This is F1. This is F2. Check what I am drawing. Hence the resultant will be this F force. Correct?
Yes,
So you
ma'am.
can now apply the triangular law of vector motion. Okay. So here in this, the vertical forces, that is F1 sine theta 1 minus F2 sine theta 2 is equal to 0. Okay. Check what I am writing.
Yes, ma'am.
Making sense now?
Yes, ma'am.
Okay. Similarly, let's talk about horizontal. F minus F1 cos theta 1 minus F2 cos theta 2 equals to 0. Okay.
Yes,
Or
ma'am.
simply you can say, Akshita, if you are not getting it, just tell that forces acting in the clockwise direction is equal to forces in the anti-clockwise direction. Okay.
Yes, ma'am.
Done?
Yes.
Okay. So basically, if suppose I have here one equilibrium position, let's say this, and here I am putting a weight which is 10 Newton. Okay. And here I am putting a weight which is 5 Newton. Done. Here is my point A, that is my center of mass. So it is acting in the upward direction. Let's say this is 15 Newton. The distance is here 4 meter, and let's say the distance of this is 2 meter. Here is B point, and the distance between these 2 points is 2 meter. Okay.
Yes, ma'am.
Done. So
Yes.
how you will going to calculate the torque at B and torque at A? Question is,
Torque at B and torque at B.
yeah, calculate torque at A and torque at B. Okay. So how you will going to perform it? It's very easy.
F,
Let's talk about A part first. Yeah. Right now I'm talking about this decimal. Done. So what
Yes.
is my clockwise? 5 into 4. Check.
Yes.
That is 20 Newton meter. Anti-clockwise 2 into 10.
Yes, ma'am.
Any doubts?
Ma'am, is it 15 or uh 5, ma'am? Oh, okay. It's 5. Okay, ma'am.
This is 5 only, no?
Yes, ma'am.
Can you find out for point B?
Yes, ma'am.
Okay, do it.
This is 1 second.
Are you done?
I 1 second. Can I just see the image, please? One.
Hmm.
Ma'am, I'll just take the image photo so I can.
Yeah, sure. Take it. Are you done?
Can I see the image, ma'am? I think like the screen just like went.
Seriously?
Yes, ma'am. Like the screen kind of went.
Now?
Yes, ma'am. Now I can see. 1 second. I can just scroll up a bit. Like one. Yeah.
Okay, let's talk over here. So, if we talk about clockwise, so I guess it will be 5 into 8. 4 to 2 for B
5
position. So 5 into 8,
into 8.
done. 10 plus 10 into 2, done. Let's talk about anti-clockwise now. So anti-clockwise will be 15.
Yes, ma'am.
Multiply 4. So how many clockwise? 10 and 5. 10 is 2 meters away. So 10 into 2 plus 5 into 8. It is 8 meters away from B position. Done. What is anti-clockwise? 15. How much it is away? 4. So 15 into 4. Done.
Yes, ma'am. But I'm just little bit confused. But I think like because all these are like on the same line. Like I'm not able to imagine the clockwise and anti-clockwise.
Acha. Okay, then I will explain it thoroughly in the next class. Don't worry. I need to explain this part then. If you're not, I have thought you are getting it. It's okay. I will explain it. Okay, I will give you 2, 3 more examples. Fine, Akshita?
Okay.
Bye.
Bye, ma'am. Thank you, ma'am.
Yeah.